Hello friends. So in this session we will discuss certain more areas of new technology, and one by one I am going to cover those topics, the basic points, applications and how the developments are all about. तो मैं इस सेशन में जितने भी ऐसे इंपॉर्टेंट और भी नए डेवलपमेंट हुए हैं नए टेक्नोलॉजी एरियाज में, उसको मैं एक एक करके चर्चा करूंगा. लेट्स बिगिन फर्स्ट विद द फर्स्ट टॉपिक, क्वांटम डॉट. क्वांटम डॉट टेक्नोलॉजी. Quantum dot. I am very sure you would have read about quantum dot in current affair material. कहीं ना कहीं कुछ ना कुछ आपको उसके बारे में जानकारी होगी. क्वांटम डॉट जो है, डॉट मीन्स हियर वी आर टॉकिंग अबाउट नैनो पार्टिकल. तो क्वांटम डॉट इज बेसिकली क्यू डॉट. क्वांटम डॉट टेक्नोलॉजी और क्यू डॉट टेक्नोलॉजी दैट इज बेसिकली is a part of the nano science and technology, this development of nanotechnology area. You all know what is nanotechnology, where we use nanoparticles and nanomaterials to develop applications which benefit human beings, either in agriculture, industry, space, defense, consumer products, whatever comes into that. तो नैनो टेक्नोलॉजी इस सदी का एक महत्वपूर्ण टेक्नोलॉजी है. हर तरह का इसका उपयोग ना केवल आज हम कर रहे हैं बल्कि भविष्य में और भी करेंगे. इट इज नाउ ट्रांसफॉर्मिंग ह्यूमन लाइव्स. सो क्यू डॉट और क्वांटम डॉट इज बेसिकली अ डेवलपमेंट ऑफ टेक्नोलॉजी फ्रॉम नैनो साइंस एंड टेक्नोलॉजी. क्वांटम डॉट, दिस पर्टिकुलर डेवलपमेंट, you can say it is an invention, आविष्कार, happened in 1980s. उस समय उतना ज़्यादा पोटेंशियल एप्लीकेशन नहीं था, आज इस सदी में है. तो क्वांटम डॉट टेक्नोलॉजी बेसिकली, इफ यू टेक क्वांटम डॉट, तो व्हाट इज क्वांटम डॉट? इज बेसिकली नैनो पार्टिकल. यू कैन से एटम. व्हाट डू यू मीन बाय नैनो पार्टिकल? नैनो पार्टिकल्स आर दोज एटम्स और मॉलिक्यूल्स which is in the range or size of 1 to 100 nanometers. The diameter goes from 1 nanometer to 100 nanometer. 1 nanometer 10 to power minus 9 meters के बराबर होता है. कोई भी ऐसा एटम या मॉलिक्यूल या पार्टिकल जिसका रेंज, जिसका साइज 1 से 100 नैनोमीटर के बीच में है, that is where the nano particle comes. Whether nano gold, nano silver, nano silicon, you can take any example there. Now this nano particle, quantum dot, a nanoparticle, right, which is of superconducting material. Superconducting like semiconducting, not semiconducting material. Semiconducting, you know that silicon, right? Then you are aware of germanium. All these are semiconductor. These are semiconducting nanoparticles. They are extremely small and they can conduct charge, electron. That's where quantum dot has been invented there. Depending upon the size of these particles, their interaction with light, their property to interact with light are different. क्या खास बात है इस तरह के क्वांटम डॉट का, कि यह प्रकाश या लाइट के साथ अलग अलग तरह से इंटरैक्ट करता है और वो डिपेंड करता है उसके साइज पे. रेड, ग्रीन, ब्लू, येलो, ऑरेंज, रेड, ऑल दिस कलर दैट डिपेंड्स ऑन इट्स साइज. सो हियर व्हाट इज सो इंपॉर्टेंट, दे एमिट प्योर लाइट, right, or you can even say monochromatic light of single wavelength, right? So pure light, monochromatic light of single color or single wavelength, light, monochromatic light, right? Monochromatic light, red, green, yellow, blue, orange, whatever color, and that behavior to emit such color, that wavelength, that depends on the size of such quantum dot particle. So that again it matters on the size. That size, that's where it behaves to generate or emit different colors. Today we are having application of quantum dot. इसका बहुत अच्छा एग्जाम्पल है डिस्प्ले पैनल. आज घरों में जो टीवी है ऑर्गेनिक एलईडी यूज करते हैं, ऑर्गेनिक लाइट एमिटिंग डायोड एलईडी. बैकलिट में एलईडी लाइट्स होते हैं एंड दैट जनरेट द पिक्स और पिक्सल व्हाट वी आर एबल टू सी दैट. अब बाजार में सैमसंग, सोनी, दे ऑल हैव ब्रॉट टीवी पैनल विच इज not OLED only but QLED, quantum LED. It generates high definition kind of images and the graphics there. Touch screen and all this kind of, that is based on that. So if you look at here, quantum dot technology, the quantum dots के जो applications हैं, they are going to be have various applications. First is this one, display panel, like TV or whatever display panel is there. So here organic LED, now that is getting replaced by quantum LED, quantum LED, quantum light emitting diode, right? Then the next word comes here, not only the display panel quantum LED part, even it can be of the touch screen. Electronic touch screens can be used in that. Then from the nano electronics, right, nano sensors which can sense the environment, there it could be used. Suppose that biosensor, nano biosensor, that means such kind of a tiny nano electronic based sensor which is fit inside the body and is able to sense any kind of disease or problem inside the human body. So even in terms of medical imaging, today we use MRI and those kind of CT scan in the hospitals and the labs. Now with the medical imaging, there the quantum dots can play a very important role. So already things have started, it is now in the market. 30 years back it was just in development phase, right? So जब क्वेश्चन आएगा यूपीएससी एग्जाम में तो आपको एप्लीकेशन पता होना चाहिए. क्वांटम डॉट पे अभी तक प्रश्न नहीं पूछा गया, क्वेश्चन नहीं है, तो you must be prepared for this topic in the exam, right? I'll just take you to certain website here. Let's look at here. This in a website what is given here, quantum dot or QLED, quantum dot LED light emitting diode screen panel are essentially a new type of LED backlit LCD, liquid crystal display. They make use of tiny phosphorescent crystals to react to light and electricity. Light and electricity, photon. Light is made of photon and electricity. Less than 500 nanometer in size. What is very important? Less than 500 meter. Less than 500 nanometer in size. 500 nanometer. 1 nanometer 10 to the power minus 9 meters. In size, these nanoparticles can glow. That means can generate color, can glow range of colors, varieties of colors, precisely determined by the number of atoms within. How many number of atoms are within that quantum dot, depending on that, the range of colors can be generated, right? Now within and struck by blue light, when the blue light is there, that means you see more highly saturated and accurate color than the normal average LED panel. They are in the market there, right? Now furthermore, if you look at here, how does it work? If you see here, what is quantum dot? You can see here. You can see the photograph also here on the screen. Quantum dots are new type of LED backlit LCD what glow when comes. How it work? Now you can see here. How it work? It interact with light. Every pixel on the monitor emit red, green, and blue light, primary color, red, green, blue, and their combination can produce different types of color, right? So sometimes combination of all three. Accuracy of the color of each pixel is defined by the wavelength. I've discussed that wavelength of monochromatic light, single color, single wavelength, and quantum dots can easily turn on the determined size, release the specific wavelength. Depending on the size of quantum dot particle, it can release that particular wavelength, right? That is what is said here. उसके साइज के अनुसार वो वैसा वेवलेंथ को रिलीज कर सकता है, एमिट कर सकता है, राइट? तो ये चीज़ है. तो यहाँ पे जैसे ट्यूब्स और मोर कॉमनली अरेंज इनसाइड अ फिल्म, शीट वगैरह जो होते हैं वहाँ पर होता है, प्योरेस्ट फॉर्म में होता है. अब ये देखो आप, ये चीज़ है ना QLED, ये बैकलाइट है, बैकलाइट है, उसको पास करते हैं स्क्रीन पे, राइट? यहाँ पर क्वांटम डॉट्स जो है इनहेंस फिल्म होता है. अब इसे जो रेड एंड ग्रीन ब्लू कलर, फिर यहाँ पर होता है पैनल में गया वो, फिर पैनल से यहाँ पर फिल्टर्स होते हैं और फिर ये बाहर जाता है. ये इसका प्रोसेस को बताया गया. दिस डन फॉर द प्रोसेस पार्ट ऑफ इट. नाउ कमिंग टू दिस वन हियर, एडवांटेज क्या क्या है? प्रिसाइज कलर, कलर रिमेन्स फॉर लॉन्ग टाइम, एग्जैक्ट कलर, राइट? देन प्योर कलर, हायर पिक ब्राइटनेस, ब्राइटनेस इज ऑल्सो हायर, राइट? आजकल के आपको पता है कि जो भी हम पैनल वगैरह देखते हैं उसकी ब्राइटनेस बहुत हाई होती है. एफिशिएंसी ऑफ दैट कलर विच इज एमिटेड, light efficiency will be higher, right? So here better energy efficiency. What do you mean by energy efficiency? It absorb less energy. जितना एनर्जी नॉर्मल पैनल कंज्यूम करता है उसके कंपैरिजन में QLED जो पैनल होंगे उसमें इलेक्ट्रिसिटी कंजम्पशन, बिजली की खपत विल बी लेस, एनर्जी एफिशिएंट, राइट? दैट कम्स हियर. लॉन्गर लाइफ स्पैन, लो बर्निंग, मतलब लंबे समय तक पैनल काम करेगा, जल्दी खराब नहीं होगा. देयर अनदर एडवांटेज इज देयर, राइट? सो हियर कम्स इज देयर. सो मोर रियलिस्टिक कलर एंड हायर ब्राइटनेस, रिड्यूस पावर कंजम्पशन. QLED डिस्प्ले हैव लॉन्गर प्रोडक्ट लाइफ स्पैन, मतलब आपने एक बार खरीदा तो लंबे दिनों तक चलेगा. एंड ग्रेटर रेंज ऑफ पैनल साइज, जो साइज का पैनल चाहिए 75, 85, 90, द डिफरेंट रेंज कैन बी अवेलेबल. ये इसके एडवांटेजेस हैं, है ना? थिनर साइज है, वर्सेटाइल साइज है, थिनर पैनल्स होते हैं. अब आजकल नैनो मटेरियल्स मेड ऑफ दिस काइंड ऑफ टेक्नोलॉजी, तो साइज इज बिकमिंग स्मॉलर एंड स्मॉलर. इवन द थिन, नाउ यू सी द लैपटॉप पैनल्स एंड ऑल, मोबाइल एंड ऑल दिस पैनल, all these are becoming the crisp, lighter, thinner, again because of such advancement of technology of display using quantum dot technology. So here QLED और ऑर्गेनिक LED में यही अंतर है कि इनऑर्गेनिक LED जो आज हम घरों में यूज़ करते हैं वो ऑर्गेनिक मॉलिक्यूल्स के होते हैं. उसकी जो प्योरिटी ऑफ द कलर और जो एनर्जी एफिशिएंसी है उतनी नहीं होती जितनी क्वांटम डॉट्स की होती है. दैट्स व्हाट बीइंग टॉक्ड अबाउट हियर, positive part of it, so this is what you have there. So gaming and all, video game, you have seen the high animation PS4 and video games and all, and the kind of a visibility, the visual aspect what you get, quantum dot based technology by Sony PlayStation, that enhances the experience, right? That comes. तो quantum LED का बहुत सारे यूज हो सकता है. मैंने बताया इवन वी कैन यूज फॉर बॉडी इमेजिंग, नैनो सेंसर्स, है ना, बहुत सारे ऐसे एप्लीकेशन हो सकते हैं. वेयरेबल डिवाइस में फ्यूचर में विच इज मेड ऑफ जस्ट लाइट काइंड ऑफ डिवाइस कैन हैव डिस्प्ले बेस्ड ऑन क्वांटम डॉट्स. तो थिंक ब्रॉड फ्रॉम एग्जाम पॉइंट ऑफ व्यू वेयर क्वेश्चन कैन बी आस्क्ड इन द एग्जाम, राइट? तो दैट इज वन टेक्नोलॉजी विच यू हैव टू कीप इन माइंड. अब मैं जो दूसरा टेक्नोलॉजी आ रहा हूँ नैनो टेक्नोलॉजी से ही रिलेटेड है, कार्बन नैनो ट्यूब्स, CNT, कार्बन नैनो ट्यूब्स, कार्बन नैनो ट्यूब्स. Now UPSC has already asked question on carbon nanotubes. Its application based question has been asked. Carbon nanotubes का जो है, carbon nanotubes, they're basically made of layers of carbon atoms, which is in the range of nano, 10 to power minus 9 meters, and that can have horizontal and vertical. Particular nanotube has a vertical kind of a conduction of charge or electron here. So you know that here first thing is made of carbon atoms, right? Second is that is a cylindrical tube of diameter. Now we are talking about the size, diameter of 1 to 10 nanometers. So it's like this one, the pore size, right? This is where the nano size comes, and all these are made of a carbon atom. These are all carbon atoms which are bonded together to form this. Now, one of the very important material which finds application in carbon nanotube is called graphene. But not only graphene, we can also have carbon nanotube made by other industrial processes by deposition of vapor, and can create that kind of a sheet which can be folded to become nanotubes. Today, nanotechnology has advanced to a high level. We are able to fabricate, design, develop such kind of materials in the lab, right? So यहाँ पे ये साइज है. अब इसी केस में यहाँ पे जो है what comes here, graphene, which is the thinnest material, right, and is obtained from graphite. Graphite is an allotrope of carbon, where carbon atoms are bonded in layer, and the different layers of graphite, they slide upon each other. It's a soft form of carbon. Imagine one layer of carbon that is taken out, that will form graphene, two-dimensional carbon atoms made from graphite, and that can be folded, rolled up to make carbon nanotubes, right? So here, the first thing comes here is basically two-dimensional form of graphite. Graphite is a three-dimensional form. So here you have a layer of carbon atoms bonded together. Now graphene, if you look at the size, is very small size, like nano size material. And what is important thing here? It has a fast conduction of current. So it has a high charge conduction. Right? High level of charge conduction. At the same time, not only charge conduction, even the heat and transfer and all this, and can be rolled up. It can be rolled up to make carbon nanotubes, CNT. We can form the carbon nanotube. So when you talk about this carbon atoms in a layer form, so here all these atoms which are in the layer form, it can have horizontal conduction of a charge or current, which can be used in nanoelectronic material there. Now it is rolled up. If it's a rolled up, right? If this is a rolled up to form this kind of a nanotube, carbon nanotube. So it can have a vertical conduction. It can result into vertical conduction of current and electron there. So it can have very potential use in nanoelectronics. Not only nanoelectronics, it can also find potential use application in display panel. Today, already carbon nanotubes are being used worldwide. Nanosensors, biological sensors, lightweight brake materials, right? Display panel, all these are now coming with the carbon nanotube. Like for example, NASA, American Space Agency NASA, we're building the plane which is lightweight, made of carbon nanotube. Satellite lightweight, carbon nanotube. Missile, rocket, defense technology, again lightweight. So that could have many use. And again the nanoelectronics, in terms of conduction of charge, current, carbon nanotubes being used, right? So it has got very potential use from application point of view, right? And graphene can find lots of application. Now let's go to certain website to tell you something more about the area. So let us now move to this. So I'll now come to this carbon nanotube. What you can see now, this electron microscope image. What you see here is electron microscope image of this nanotube, which is fabricated, designed and made in the lab. Now if you look at here, the purple structure of human hair fragment, what you find that, and that is and even the smaller than that, what you see, the purple color is the hair. If you take this hair under electron microscope, even smaller than that, what you see, this all are carbon nanotubes, 1000 times smaller than the human hair. Now let's look at here. See here, what is given here, I'll just read out, then I'll explain here. Like their building block graphene, right, CNTs, carbon nanotubes, are chemically bonded with sp2 bonds and extremely strong form of molecular interaction. केमिस्ट्री के तौर पे जानते हैं sp2 बॉन्ड, sp2 बॉन्ड, sp बॉन्ड. तो जैसे ग्राफीन होता है उसी के कंपैरिजन में यहाँ पर जो है sp2 बॉन्ड के साथ कार्बन एटम्स बॉन्ड, वेरी स्ट्रॉन्ग बॉन्ड. So even you can say is not only lightest or thinnest material, but also very tough, hard, right? Has a strong mechanical strength, high mechanical strength. You can see here this one, carbon nanotubes, right? That is one is that ultra high strength, low weight materials, highly conductive electrical and thermal property. It even has a thermal property high level, and you can see this make them very highly attractive. And you can see all these are carbon atoms folded together. Carbon allotrope, they've been used there, right? Electrical property of carbon nanotube is very high. It can conduct more charge. It can conduct current and the part of this, right? This is what you find in terms of kind of properties there. So their mechanical tensile strength can be 400 times that of steel. Imagine, mechanical strength of carbon nanotube can be 400 times more than the steel rod and all. Another thing here, very light material, density is 1/6 of the steel. Density is very low. Then again, what comes the next one here is the thermal conductivity is that is better than the diamond. Then it has a greater surface area, the ratio part of it, then greater than 1000 here, length wise. The tip surface area has a very high area there. So there's different type of carbon materials which have been developed there and can be used there. You can see that when you go to YouTube channel, you will find many such materials are there. Nanofiber, right, nano things.
To a hot topic in the world of nanotechnology. But what are they?
This is an animation form.
Analyzing the word nanotube.
What do you find here?
Nano comes from the Greek for dwarf, and as a prefix means 1,000th of a million.
You know that nano.
That is 0.000000001.
10 to the minus 9 meters.
Very tiny.
Right?
Tube is a cylinder. Everyone knows what a tube is.
And you can see here the tube here.
Very tiny cylinder.
Tiny cylinder is there. What I've already explained in the session here.
In the core of a pencil, it's graphite. Graphite is made up of layers.
Now this is the graphite, layers of carbon there. If you take one layer, that is called graphene.
The structure of a carbon nanotube.
Right?
If we take this layer and roll it,
Just to make you understand through a diagram, there is no saying that if we can take it there and fold it there, so we can make the carbon nanotube,
if we roll the
CNT.
layer only half as long, we'd obtain a tube of half the diameter, but it would still have this exact shape because we rolled the layer.
छोटे जितने साइज में हम जा सकते हैं, डायमीटर जितना छोटा हो सकता है,
In another direction,
है ना,
like here, we've
उतना हो
chosen one
सकता
which
है.
looks more like an armchair, so the tube has an armchair shape along
तो
the
ये
sides.
वापस इसको डेमोन्स्ट्रेट करके दिखाया जा रहा है. अभी होगा कार्बन नैनोट्यूब को आप देख रहे हैं स्ट्रक्चर जैसा
One
बनता
layer
है
can be
वहाँ
rolled
पर,
in any direction, and that defines the
और ये
final
कोई भी
shape
डायरेक्शन में
of
भी हो
the
सकता
tube.
है. अब जैसे ये डायरेक्शन है,
The way you
डायगोनल
roll the
जो
tube
है
is important because
है ना,
it
अब ये ऐसे फोल्ड किया गया,
electronic properties.
अब ये चीज़ है, तो जैसा हम फोल्ड करें वैसा डिज़ाइन हो सकता है और उसके अलग इलेक्ट्रिकल प्रॉपर्टीज हो सकते हैं। ये दूसरा लेयर है, ग्राफीन को फोल्ड कर बनाया गया है, राइट। तो ये चीज़ है 1 लेयर, बट अब जब ऐसे अब क्या है कि 2 लेयर्स का बनाया गया है, 3 लेयर्स का बनाया गया है कार्बन नैनोट्यूब्स। अब देखिए ये, तो ये कैन कॉन्सेंट्रिक सर्कल्स कैन बी देयर, है ना, ये सारी चीज़ जो है, तो हम ऐसे कॉन्सेंट्रिक सर्कल्स के अलग अलग कार्बन नैनोट्यूब बना सकते हैं। अब जैसे ये चीज़ है, वेरी लाइट काइंड ऑफ मटेरियल देयर, ये कार्बन, ये एप्लीकेशन है, वेरी लाइट मटेरियल बनाया गया है वहाँ पर, ठीक है। सो दैट इज what you find here graphically shown to you कि what exactly the carbon nanotube could be there and how it can be used there. So it can have a variety of applications in real life, right? This is what you have seen here. So discovered carbon nanotubes in 1991. 1991 में इसको डिस्कवर किया गया था कार्बन नैनोट्यूब को, और उसके बाद में ग्राफीन को डिस्कवर किया गया, इन्वेंट किया गया, बनाया गया। अब उसके काफ़ी डेवलपमेंट हुए हैं। अब जैसे ये चीज़ है कार्बन नैनोट्यूब का, ये सारा है ना, सिंगल वॉल कार्बन नैनोट्यूब 1993 में हुआ है, ग्रीनलैंड आइस कोर में यहाँ पर है, बहुत सारी चीज़ें हैं, इवन नेचुरल वर्ल्ड में भी हो सकता है ना, ये सारी चीज़ दिखाया गया है, प्लानेटरी नेबुला में पाया गया है वहाँ पर। तो ये कार्बन नैनोट्यूब कैसे बनाया जाता है, अब ये ध्यान रखना है, लैब में हम कार्बन नैनोट्यूब बनाते हैं विद अ मेथड कॉल्ड CVD, कार्बन वेपर डिपोजिशन टेक्निक। CVD technique, carbon atoms which is in the vapor form are deposited on the layer and then folded to become carbon nanotubes. It's a very advanced nanotechnology method. So carbon vapor जो chemical vapor deposition किया है, carbon vapor उसके थ्रू बनाया जाता है, and we can construct with the atom. What you see is the atom with the, what you see the cylindrical thing, that is a carbon nanotube which has been developed there. उसको प्यूरिफाई किया जाता है, फिर उसको यूज़ किया जाता है। अब यहाँ पे जैसे क्या क्या चीज़ें हैं, अगर देखा जाए इसका एक बहुत अच्छा एप्लीकेशन की बात की जा रही है, स्पेस एलिवेटर। इमेजिन दैट इन फ्यूचर स्पेस टूरिज्म फ्रॉम अर्थ टू आउटर स्पेस, एंड दैट एलिवेटर विच विल कैरी ह्यूमन इज मेड ऑफ कार्बन नैनोट्यूब, वेरी स्ट्रॉन्ग लाइट वेट काइंड ऑफ अ मटीरियल ऑफ दैट स्पेस एलिवेटर दैट इज गिवन हियर। कार्बन नैनो फाइबर जो है, इसको है ना नैनो फाइबर के तौर पे हम यूज़ कर सकते हैं, स्मार्ट फैब्रिक इन ड्रेस वगैरह में हो सकता है, गारमेंट में हो सकता है, इलेक्ट्रॉनिक सेंसर बन सकता है कार्बन नैनोट्यूब से, है ना। जो शूज़ होते हैं, ब्रेक शू और व्हीकल्स वगैरह में, वहाँ कार्बन नैनोट्यूब का यूज़ हो सकता है। इवन साइंटिस्ट हैव यूज कार्बन नैनोट्यूब टू डेवलप आर्टिफिशियल काइंड ऑफ ब्लड वेसल, इस पर काम चल रहा है। तो बहुत सारे इसके एप्लीकेशंस हैं यहाँ पर जो हैं, जैसे कि स्पोर्टिंग गुड्स हैं, बाइसाइकिल फ्रेम, टेनिस रैकेट, हॉकी स्टिक, गोल्फ क्लब, देन बॉल्स, कयाक, ऑल दिस मटेरियल मेड ऑफ कार्बन नैनोट्यूब्स। फिर यहाँ पर याटिंग जो है, सेल बोर्ड, टेक्सटाइल, है ना, स्मार्ट फैब्रिक्स, राइट, इलेक्ट्रिकली कंडक्टिंग टेक्सटाइल्स वगैरह, स्मार्ट फैब्रिक्स, ऑटोमोटिव में, एरोनॉटिक्स में, स्पेस में, लाइट वेट, हाई स्ट्रेंथ स्ट्रक्चरल कंपोजिट, है ना, कार्बन कंपोजिट मटेरियल। इंडस्ट्रियल इंजीनियरिंग में विंड टर्बाइन, रोटर, इंडस्ट्रियल रोटर टर्बाइन जो होते हैं, या जो इंजन्स होते हैं, वहाँ उसके पार्ट में जो रोबोट आर्म जो है, जैसे इंडस्ट्रियल रोबोट्स वगैरह का आर्म वगैरह हो गया। इलेक्ट्रोस्टैटिक चार्ज प्रोटेक्शन जो है, जहाँ पे चार्ज को प्रोटेक्ट करने के लिए इलेक्ट्रोस्टैटिक जो है, इलेक्ट्रोस्टैटिक तौर पे उसको वहाँ पर बनाया जा रहा है वहाँ पर, ठीक है। तो बहुत सारे यहाँ पर कैटलिस्ट, इवन फॉर कैटलिस्ट, व्हाट इज कैटलिस्ट, विच स्पीड ऑफ द रिएक्शन, विच इनहांस द रेट ऑफ द रिएक्शन। Even that point of view, carbon nanotubes can be used there, right? तो ये सारी चीज़ें यहाँ पर जो which you see here, which is given in mechanically interlocked carbon nanotubes, mint, which also has been now developed there. This is used as a catalyst in helping in chemical reactions, right? Transistors, electronic transistors used in semiconducting chips, IC layout, semiconducting chip or electronic component transistor. That could be carbon nanotubes here. You will see the image here, right? So lot of development, 10 nanometer size diameter, and lot of development is there. So you can get direct question. Let's say you get a question in the main exam, then you have to write about nanotechnology एग्जाम्पल एंड द डेवलपमेंट एंड एप्लीकेशन। प्रीलिम्स एग्जाम में डायरेक्ट पूछा जाएगा, एप्लीकेशंस होंगे वहाँ पर, राइट। तो ये चीज़ को ध्यान में रखना है। तो मैंने सेकेंड टेक्नोलॉजी जो डिस्कस किया है क्वांटम डॉट के बाद कार्बन नैनोट्यूब, उसी कॉन्टेक्स्ट में मैंने ग्राफीन के बारे में बताया, राइट। अब मैं कुछ और एडवांस एरिया पे आता हूँ जो कि काफ़ी न्यूज़ में रहा है, दैट इज इन टर्म्स ऑफ रोबोटिक्स। Not only prelims exam, this topic is also important for main examination, robot and robotic development. और इसी के साथ साथ AI, artificial intelligence, that is making headline. You all have seen in the movies, science fiction, robot. So what is a robot? A robot is a programmed machine to carry out human task, right? They are programmed in such a way that it can do the task which a man does. Robotic is the area or the field which combine mechanical engineering, because they have actuator, arm, right, all the machinery parts are there, and electronic and electrical engineering. It has electronic sensors, it can sense the environment, receive the command and all this one, and then electrical parts, electronics things. And third area is computer science and engineering, the software which make the system to work, the robot work there, advanced programming, software program to understand the human command and then execute the task. So basically it is a area of this mechatronics, and a mechatronics, that is a where one use the science of robotics comes into that, is a part of mechanical engineering, electronics, and then in terms of computer science. 40-50 years back the development was more industrial. It was very simple type of robotic devices, but today in 21st century it has become more and more advanced with not only the normal industrial kind of robot, but medical robot, but defense, many other robot, even human-like robot, humanoid, they have been developed, right? And future is going to be more and more advanced in the field of robotics. So if you take here mechatronics here, so it's a programmed system there, programmed machines, right? And now from simple to it is getting more and more complex. Now what is happening here in the robotics there? In terms of the artificial intelligence, the computer program, the software, which works with the machine learning, right, and deep learning, just like human brain, understand like human, can sense the environment, can have the recognition, text, word, voice, visual, that kind of, and having that kind of understanding what human does have. That is through the AI on the part of the robotics, is making it very, very advanced. Artificial intelligence, right? And here very potential application there, like industry. See, robot can be movable kind of thing, can be stationary. You have seen the manufacturing units, assembly units, pick and drop, right, in terms of mixing, packaging, all these robotics being. You know that many times you have come across the word industry 4.0. There's use of advanced robots with AI system. So here industrial application, then medical science, robotic surgery, medical science there, trained surgeon which can carry out robotic surgery of kidney or lung or any such kind of thing there. The loss of blood will be less, healing will be fast. That has come up there. Then not only this one, even you know that geological exploration, deep mining, then deep sea survey. Again we can use submersible or such kind of a device which are robotic devices, like here mining, deep sea, then you know hazardous occupation like space, and space mission. You know the space mission, ISRO has developed Chandrayaan mission, lunar mission, Chandrayaan 2 rover. NASA has been landing many such rovers over red planet Mars, like Curiosity rover, Perseverance. These are all robotics. Then you know that defense application. You know that defense part, if you look at, then in terms of defense, what comes here? Defense, if you look at defense, like a drone, unmanned aerial vehicle, remotely operated vehicle, unmanned aerial vehicles, drones, robo soldiers, which we don't require human defense personnel to there. It can work automatic, even automation part of it, right? So space, defense, any area, we can use that. And now what I said here, that now with this part, humanoids have come up. Human-like robot, which can talk like human, which can recognize, understand like human. And you all know that in current news, one of the very important name comes Sophia the robot. So if we take here Sophia is one of the very advanced robot. She has appeared in number of TV shows. She has attended number of conferences, and Sophia has been built by Hansen Robotics. It's a Hong Kong based company, right, that has built Sophia and works with all such kind of latest kind of thing. It has a complete aspect of a human, and it has got Saudi Arabia citizenship. यह विश्व की पहली ऐसी रोबोट है जिसको सऊदी अरेबिया ने नागरिकता दे रखा है. That's what this particular robot is all about. Hansen Robotics there. It personifies everything on that. It has a voice recognition, everything is there. Artificial intelligence, cognitive part of it, recognize everything. It can connect with the human. It can talk with humans. Right? Hansen Robotics has been working to develop such kind of robots there. Right? इसमें एक और टेक्नोलॉजी यूज होता है, ब्लॉकचेन टेक्नोलॉजी. That means it is secured. That cannot be easily hacked. Right? Then I'll give you another example here. There's another company called SoftBank Robotics. SoftBank Robotics. And there's a world famous robot called Now. Then other robot Pepper. And they're used for customer care. Right? Old age people support and assistant. House surveillance and support. Bank, offices. This type of robots has been used. 2-foot robots have been used there. SoftBank Robotics have done. Again, based on AI, artificial intelligence. So if you see here, paper. There's a paper here. Then you can see here, student support. Right? Where the robots can be used there. So if you look at here, cleaning part of it. Right? They have been in the news. Paper. Office and all this one. It has been in the news there, and all this you'll find that they have found the part of its application part, right? They have been in the part of it. So SoftBank Robotics, which has developed such robot there. You can see small robot. Even the child, even for normal kind of talk and entertainment, that kind of is there. What we see in the movie like Chitti, Rajinikanth, 2.0, right, robot. Now it has become reality, right? Now another I'll find here, IDA. This is the first robot who is a painter, artist, can draw, sketch, make painting. And again, artificial intelligence based humanoid robot, IDA. This is IDA. What you see her photograph. This has been developed, and she can draw the world's first ultra realistic humanoid robot artist. University of Oxford, UK. There in terms of, and there's the art. It can draw the part of it. It can draw. You can see here with her hand, she can make sketch and all graphics. Right? It has made even sculpture, artwork. In UK, it has been developed. This IDA is there, right? But you can see the photograph here. World's first kind of a robot artist, which has been developed, right? And painting, sculpture, right? In the time of online avatar like AI chatbot, Alexa, we use Alexa. Apple, we use Siri, right? Then IDA as a robotic artist has become very, very important, right? Which has come into the application part. This is how she is there. So this is what she has appeared in the TED talk also there. She can talk also there, just like Sophia. TED talk. There she was there. IDA. Oxford University there. And she's talking to the normal audience there. And her hand, she can do the artwork. So she has got same kind of human intelligence by which it can imagine, think and draw the things on the canvas, right? IDA could be the part of it. Right? So that's what it is transforming the entire landscape of robotics, right? AI is a very powerful tool. AI can make short stories, poems. AI can solve human complex problems. AI can help us in terms of controlling law and order, in terms of finding out any kind of a suspect from the image and everything there. AI as an application in robotics, like humanoid robots, can give us the same kind of thing what a man or a human has got. So it is transforming entire landscape of robotic technology, right? And AI is a game changer. Now this is the worldwide development, but I will bring a development from India also there. Invento Robotics has developed India's humanoid robot called Mitra. So let's look at here, Mitra Robot. HDFC Bank, then hospitals like Max, Apollo, number of customer care aspect there. Mitra Robot can be used there. So if we talk about Mitra Robot here, so this is where you'll find Mitra Robot. Mitra Robot, this has been displayed in retail shop, Big Bazaar, retail shop, there the Mitra is all about. This is the Mitra.
Welcome to the Soul Space Mall. I am the Mitra Robot and I will be your shopping assistant for today. Let me check your body
Shopping
temperature.
assistant.
Please look into a camera.
COVID time, body temperature.
Optimal body temperature detected.
Checking
What are
the
you looking for
body
today?
temperature of the customer.
Trendy bags collection.
Of course.
Now
we
the
have
customer is
the
asking
following options.
for
Let
any
me
kind of
take you
dress.
there.
Now Mitra is taking to that particular place where that particular cloth is available there.
Here you go.
Thank you,
This
Mitra.
one.
Can you help me?
So in the
Absolutely. You will find our smartwatches collection here.
watch collection,
What do you think is better, G-Shock or the smartwatch?
I say the smartwatch since you are looking for an upgrade.
even depending on choice or interest of the person, Mitra can give
Please
the
choose
answer.
from one of the quiz category. GK quiz
And has a
suggests
screen
you
here.
among the following wrote Sanskrit
One
grammar.
can select there.
Correct. Hitler's party, which came into power in 1933, is no.
It gives the information about the part of it.
Correct. Check out your score.
Yay! Thank you, Mitra.
Again, autonomous based robot based AI system,
Mitra,
Could we grab a quick bite somewhere?
Sure.
right? So it has a will by which it can move. It is not with that advanced like Sophia or IDA or Now and Pepper, but it is India's development of robot. Indian development is there. So Indian development is because we can do that one, right? So that is what you find. Any kind of assistance the Mitra can do. And it was unveiled by the Prime Minister Narendra Modi during a conference in Hyderabad,
You can check in with the Robotics, sir.
right?
Please let me know your phone number and email ID.
Even phone number, email ID.
45
If you say to the Mitra,
961.
Mitra has all the data in the part of the software there.
How many stars would you like to give us?
Even the last star rating can be done there, right? So that is what you come across about the Mitra system there. Inventor Robotics, right? There is a female version of Mitra called as a Mitri. I'll show you that. There is also a female version, what is called Mitri. See here, grab attention, right? It can talk to the humans. So you have this one, the model of the robot here, and then you can see here this one, face recognition, AI, deep learning. It works there, autonomous navigation. Without any, it can move with this fleet management, central database. There's a screen there. You can see here, now you have seen the video there, that in terms of supermarket, mall, hospitals, Fortis hospital. They're using for scanning of body temperature and all during the time of COVID. Then again, event management, senior care, old age people care, right? So this is what has happened here. It has come in the news also there. So there are this type of development, not only worldwide, even in India, is going to transform our human lives. Such kind of humanoids are being worked out. Hazardous occupation where man will be at risk, such kind of robots can be used, right? So what I've done here, I have discussed in today's session about area of new technology. One is quantum dot, graphene, carbon nanotubes, and then I have gone to robotics and discussed about humanoid robots, right? So in the upcoming part of the session, we will also go to certain more new technology area, right? So one by one, I am covering all such latest areas of or the topics where UPSC can ask question there, right? So very soon we'll move to the next session and where I'll discuss new topics. Thank you everyone.